signed up for it? Have you all been on Blackboard already? Excellent. All right. The project descriptions are going to go on Blackboard. You're going to submit the projects on Gradescope this semester. And we're going to see how well this works. I hope it's good. I have Discord. As I said, get on there. Use this to get to ask questions. There is a one thing is that you're. Oh, I haven't logged on to Discord here. But anyway, there's a welcome channel, and on that channel there's a bot that's posted a thing that lists different classes. Go click on the one with the 4 so that you can see our class channel. The intention for that is so that way you don't have to see the channels for the other classes, which doesn't matter as much this semester because in the summer I'm just teaching Computing 4. But during the main semester, it's like I don't want my students to see things for my software engineering class and be like, so about your paper that's due tonight, right? And have all of you panic when you see that, and then go and see that it's in the other channel and be like, oh, we don't have a paper due, right? That'd be scary. Or their test. I'm sure that would make you all comfortable, right? And likewise, they don't want to see, the 50 questions that come in very short succession about all of you asking about your projects. So it cuts both ways. As I said, please make it so that the handle that we see in the channel resembles your real name, so that way I can go and be like, okay, you need help and you need me to go look at your submission. Here's who submitted. If you've got, your handle is, ProGamer420, I'm gonna be like, yeah, who's this? I got office hours, I got in-person ones from 1 to 3-ish. If you're not there at 3, then I'll probably pick up and leave and go home. And if you are, we can keep doing stuff. I got office hours on Discord on the off days, so that way we have flexibility on where we are. I know some people prefer in person, and some people prefer to work stuff from home over Discord. So I have both options. Questions over that on anything so far? What's all of your most important question that you want to ask? None of you have any big important questions that you always want to ask every single one of your classes? What's the number one question that students are going to always have for every single class on the first day?
Oh yeah. Do we have exams?
Do we have exams? That's probably the number 2 question, but that basically falls into sort of the category of how am I graded, right? What do I have to do to get an A, yada, 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 that stuff. So, we have programs are worth the bulk of your grade, about 2/3 of it, right? We have quizzes that are worth 20% of your grade. We have a final portfolio that you'll submit at the very end of the semester that is a writing thing that's worth 15% of your grade. Yes, you're going to have to do a little bit of writing for this class. The portfolio is going to be sort of a collection of everything you've done this semester, explaining, hey, what did I do? What did I learn? Here's my code. It's a kind of a handy thing to have when you start going on to job interviews, to be like, here's what I did, right? So that'll be at the end of the semester, that's worth 15%. Grading scale here. Each category is weighted by points, so quiz points are all the same, project points are all the same, but project points and quiz points are not the same. So here's the question that you asked. Those are like your 4 favorite words in the English language, right? There are no exams. You do have 6 quizzes. And they're kind of big for quizzes, but they're definitely smaller than exams. Each of the quizzes is going to be a front and a back. Make sure that you don't forget to check the back. Fortunately, last summer when that happened on the first quiz, I was able to catch the guy before he left. You do have the final portfolio that you submit at the end of the semester that sort of takes the place of your final exam. And the big quizzes are, like third of exams, right? There's 6 quizzes. We'll take them in class. They're going to mostly be on Wednesdays. The last one is going to be on a Monday, so that way we don't have to come in on Wednesday. You're like, pro, con. No class Wednesday, but have to take on a Monday. I will drop your lowest quiz, so yay! Only 5 of them count. So that means that they're basically worth 4% apiece, right? Questions? You're going to submit your code onto Gradescope. Your submissions need to include a makefile. I have provided one for the first project to get you started. If you do a normal-ish submission for Project 0, you probably don't even need to edit it for Project 0. You will need to edit it for your other projects. All of your submissions have to use a makefile, and they need to compile using G++. You need to use the WAL, WAIR pedantic flags. I'm going to force you to deal with all of your warnings. You can't just be like, oh, it's a warning. You have to enable the warnings, and you have to actually deal with them and treat them as errors. You may optionally and probably should use the standard C++ 17 and -G flags. C++ 11, 14, 17 all have added new stuff. So some of them you're going to have to use. So at the very least, you're going to need to enable C++ 11 by the middle of the semester. Might as well go straight to 17, right? -G will give you some debugging stuff that'll help when you try to fix your programs. I don't really care what tools you use for, doing your editing. I know a lot of you have preferred IDEs by now because you've had 3 or 4 semesters or longer for some of you have been coding for. So you might have preferences on tools. I'll be using VS Code during class, but I'm not going to force you to. It's sort of your choice. You're going to submit your code onto Gradescope. Gradescope is the arbiter of whether your code compiles. If Gradescope is going to, when you submit it, run the autograder. The autograder will then, I've got a thing there that is going to check that your code compiles and builds particular files. So if it says you got those files, you're cool, and if it says that you don't have those files, well, I'm pretty sure it lets you resubmit. Up until the deadline. There's going to be some parts that are auto-graded, some parts that are manually graded. Some of the projects will have 80% of it is auto-graded and 20% is manually graded, and some of them are going to be the other way around. At the very least, though, the auto-grader will be able to compile your code and then check that you've got the right files. So at the very least, you'll be able to check that, okay, I got the right folder name, I've got the thing, it creates the program with the right name. And at the very least, I have to read through your readmes and stuff like that. Okay. Questions? Oh, yes.
Is there going to be any resubmissions of assignments or no?
So the stuff that you submit, I believe Gradescope will let you just resubmit stuff until the deadline. So you go, you make your submission, you're like, oh, I made the program name the wrong thing. It'll tell you you're missing these files, go fix that. I believe it should let you just resubmit stuff. There will be some redo assignments where you'll be able to be like, all right, I did terribly on this project. I had no time because, you know, I had my cousin's wedding to go to, right? And I just didn't have time to do the project. So there will be it's probably going to be 2 redo assignments where you get to pick one assignment and redo it. That I have to figure out how that's going to work with auto grading stuff. So we're going to deal with that when we get to it. There's a few things that I'm figuring out as we're going this semester, so that'll be fun. Other questions? So, in some of your earlier classes, you had to do things the hard way, right? Computing 2 is sort of the biggest thing there, where you had to do almost everything the hard way, right? Well, welcome to Computing 4, where you get nice things. You're allowed to use basically all the stuff in the standard library. So you're allowed to use strings, streams, the entire STL, smart pointers, exception, the algorithm, functional, regex, and random libraries. You're just allowed to use all of that. Sort of the first 3 things are all stuff that you talked about in Computing 3, right? And the stuff below that is stuff that we'll talk about later this semester. But even now, you're allowed to go use all of it. If you want to go and use smart pointers in PS1, you may absolutely do that. And in fact, it's probably not necessarily a terrible idea. We'll also be doing some stuff with the Boost and SFML libraries, and in fact, I will be making you use them at various points in time. So we will be using SFML for Project 0, Project 1B, Project 2, Project 3, Project 4. And I guess at that point, I think we basically stop. I'm going to make you use the Boost unit testing library for several projects. We'll be using the Boost datetime library for the last project. So you'll get some experience with a few different libraries. So yes, welcome to Computing 4, where you get to use some nice things. Questions? If stuff goes wrong, almost everything you submit this semester is going to be on Gradescope. So Gradescope has stuff for being able to request regrades. So all of your resubmissions need to be made through Gradescope. You should make your resubmission or your regrade request sooner rather than later. If you wait until the end of June to be like, hey, why did I lose these points on project 1? I'm going to be like, why didn't you ask me a month ago? Right? Also, you have to include a reason, and I feel I deserve more points is not a reason. I worked really hard. Yeah, I don't care. Well, you said that you needed this, and isn't this thing equivalent? That's a reason. I worked really hard and made just one more point to get a B-. That's not a reason. Okay, questions? Late work is minus 10% per day. I don't have an easy way to make it be of the points that you earned on Gradescope, so it's going to be out of the points possible. Sorry. One of the things for me to figure out as time goes on, but on the other hand, this is a summer, and so one day is comparatively a lot more than one day during the normal semesters, so it might still be overall in your favor. You get 1 week as the maximum to resubmit stuff. Gradescope will do an actual hard cutoff then, so I don't have to worry about people going and submitting stuff, 3 weeks later and hoping to get something. If you make an on-time submission, then you get a 24-hour grace period after the deadline before I start applying late penalties. That should be Gradescope as the final arbiter on submission times this semester instead of Blackboard. Okay. Also, quizzes are going to be in class mostly on Wednesdays. I will announce all of the quizzes ahead of time so you don't have to worry about pop quizzes. I know you guys love those so much, right? And by that I mean you absolutely hate them. If you're going to miss a quiz, you need to let me know as soon as you can. Earlier is better. I am going to try to get quizzes graded overnight, so that we can talk about them on Thursday, and I don't let people make up quizzes after I have gone and released the quiz. So if you wait until Thursday afternoon to be like, sorry, I missed class yesterday, can I make up the quiz? My answer is going to be no. Fortunately, the one dropped quiz you get can include a quiz that you missed. So yay, right? Preferably you don't want to use it for that though, right? Okay, questions? And then everyone's least favorite topic, plagiarism. You are expected to do your own work. Don't copy code from anywhere. You can't reuse work from another class, including if you have to retake this class. Don't take code from a friend. Don't take code from the internet. I'm aware of sites like Chegg. It's not going to work out very well for you. I will compare your submissions against other submissions. So the MOS tool is really, really good. Renaming variables, I can figure that out. If you take a function, move it elsewhere in the file, it's still gonna work. Changing your indentation does absolutely nothing. I can see through, most of the stuff that students would do to try to obfuscate their code a little bit. Also, don't share your code with other students, because if they copy from you, you will also be penalized. The punishment for giving your code to another student and them using your code is the same. Standard offense is first offense will get a 0 on the assignment, and your final grade will be reduced 1/2 mark. So if you had a B-, you get a C+. If you had a B+, you get a B. Second offense, you fail the course instantly. I request that you get a non-deletable F, which means even if you retake the course, it stays on your transcript. Gonna really lower your GPA. And I will request your removal from the CS major. Because frankly, by this point, you should be able to do stuff on your own. If you need to cheat on 2 projects, you don't deserve to be a computer scientist. Back at Michigan State, I'd be like, and you don't deserve to be an engineer, because we were in the College of Engineering there. If you do something completely, absolutely egregious, I might request additional penalties. Now, I don't have to worry about, you trying to take an exam for somebody else, because, well, we don't have exams in this class, so yay! Anything that requires me to contact the FBI, though, is probably an egregious offense. Addendum to the cheating policy. As I said, I know about Chegg and sites like that. And I know that for a couple of the projects, there might be solutions on Chegg. Going and taking answers from Chegg is an instant failure. Period, full stop. If you post the problem on Chegg or if you take an answer from Chegg, you fail. Non-deletable F. Full stop. Okay. Questions, comments, concerns? Okay. If you have an accommodation or anything, please let me know as soon as possible. You can do it after class, come to my office hours, send me an email, whatever. There's the accommodation site. You go through them, you can get your accommodations, get your extra time or whatever. That's the most common thing that I have to deal with. My notes are going to be posted on site or on Blackboard. I've requested recordings, so those should be available after class. So those are, the other common things, and that should already be dealt with. Questions? Who's excited? I see a couple nods, hands. Who's excited? Okay, I got some people who are sort of excited. All right, whatever. We'll have some time to do stuff. So, I said we're gonna be using SFML this semester. We got some tools. You need to get stuff set up. So, you probably want a Linux work environment. And most of you have Windows computers, right? There's a couple of you who've got Macs. Your best thing is to try to contact some students from previous semesters, because I know there's a few fiddly things, and I don't have a Mac, and so my ability to help get some of your stuff set up there is a little bit limited. For those of you who are on Windows machines, my recommendation is you probably want to try the Windows subsystem for Linux thing. Which, for most of you, then, it's like, well, if you go to the store, it's up, and then if you search Ubuntu, then you get this. It's free. I've already got it set up. This is probably the easiest way to get WSL set up. The other thing that you're going to want to do, or want to make sure that you do, is features. Turn Windows features on and off. There's a Windows subsystem for Linux feature that will be near the very bottom, because W is one of the last letters of the alphabet. So the Windows subsystem for Linux feature, you'll want to make sure that that is also turned on. Once you do that, you start up, you run WSL. It's going to then do a little bit of stuff and then force you to restart. So I've got myself my terminal. Once you've got stuff set up, then this will work very nicely. And so it's like, hey, I got myself a terminal, yay! All of my beautiful Linux stuff. If you're on Windows 11, that's probably all you really have to do to get all that set up for doing. Well, then you'll have to go and be like, all right, sudo apt-get update, make sure all of your stuff is updated. And then after that, I've got on my setup instructions, here's a whole bunch of stuff you're gonna need this semester. Which I think one of which, It's been a little while since I've updated on this computer. Maybe I should open up a separate tab. All right. So, older version of Makefile, yeah. I've got an updated Makefile that's on Blackboard for Project Zero. It's similar to this one, but it's got a few things that's been updated to make life easier for future projects. Then, this code is code that you are going to get off of the SFML website, which is linked in the Project Zero description. So, SFML and Linux. So for Project Zero, it basically says, go get all of your tools set up, come to this page. There is then a sample getting started SFML project or thing. You copy this code. This is the one case where I'm like, you need to copy code, right? You start with this, you paste it in here, make, and then we'll run SFML app, and if you've got everything set up, you got a window that has a little green circle. If you submit this, you still get like 2/3 of all of your points, right? Maybe it's only a half. I'd have to check the rubric. But if you get this, all of your stuff is set up, you've done the hard part. For Project Zero, then you have to go change the window size, get it to include an image, have it display the image, have it do stuff like move the image when you press keys. Most people are like, all right, WASD or arrow keys, move the image, boom, you're done. You get to pick what image you want. I don't really particularly care too much which image you pick. Please keep it safe for work. I don't want to see all of your disturbing stuff. Because, you know, I do have to actually run your programs. But that's Project Zero. Most of the hard part is the making sure that you get all of your tools set up. If you've got a Linux box already, it's really, really easy because you go sudo apt-get install smldev and a few other things that you need for other projects. Do the Hello World project, make your amends. If you've got Windows, you got your couple extra steps to install your Linux-like tools. If you're on Mac, then there's some stuff for Brew that I don't know all the details for because I don't have a Mac. Okay, questions, comments, concerns? So, yeah, let's see. We'll be using SFML. Project Zero is basically to get it set up. I do have a setup document for suggestions on how to get set up. The most destructive option is you can install Linux directly, dual boot. If you're just trialing it and you're like, I don't know if I for sure want to be spending all of my time on Linux yet, that's probably not your best first choice. But if you do it, it's going to be the one that's going to be, you know, the most certain. It's just also destructive, and if you screw up that first step, you can damage everything else, right? VirtualBox is an option. I find VirtualBox to be a little finicky sometimes on getting it to actually run. But once it does run, it's probably your next actual most faithful option. You have the option that you could SSH into a remote machine or go into one of the computer labs, right? Most of the lab computers, I think, dual boot Windows and Linux, so you can restart them and then tell them to boot into Ubuntu. Or is it Debian? What do the labs use? I think it might be Debian. Or, you know, do what I just demoed and use Windows Subsystem for Linux, which is sort of my favorite option. If you're on Windows 10, you might have to get X server stuff, which is the really annoying. It's the actual annoying part for doing PS0. If you're on Windows 11, it should just work. If you're on Windows 10, you might need to get yourself the X server, and you have to remember to run the X server every single time you want to do your program stuff. You turn it on when you start working on your project, you turn it off when you're done. And then you have to configure your bash RC stuff, and it's mildly annoying. But you get your stuff set up. My setup instructions include, hey, go get the X11 apps, run the X clock utility. Because that's an easy thing to do to just check that you've got your GUI stuff set up. If the clock appears, you're all good. If it doesn't appear, you need to go get yourself an X server. Then you can, doing that makes sure that's not a thing with you running your SFML app, and is your platform set up correctly. Get SFML installed. If you're on Ubuntu, it's really easy. Sudo apt-get install lib SFML dev. Boom, easy, right? I've also got other things you'll probably want later in the semester. You'll need the libboost test for doing the unit tests for other projects. You'll need regex and datetime for the last project. You'll need Python 3 for doing linting stuff for a bunch of projects. It's like, all right, might as well do all the installation now while you're in installing mood, right? As opposed to have to do them every single project, right? And then we did our hello SML, link you to the site where you can get it. It draws a little window like that. And that's project 0. Questions, comments, concerns? I know this part so far has been me talking at you a lot. We'll do some more interactive stuff for most of the rest of the class. So we're going to trial some flipped classroom things where we're going to build a program collaboratively together. Hopefully work on some of those skills that you need for doing your projects that you are actually assigned. I know up to this point, you've basically done little tiny things and you don't know how to build a big project. So we're going to build some bigger projects in class. So we'll take a little bit of a break, and after break, we're going to build Evil Hangman. Questions, comments, concerns? All right. How long do you guys want for breaks? Do you want, 5 minutes, 10 minutes, sort of halfway in between? How long do you all need? Nobody has an opinion on how long we break for? I know you absolutely don't want to hear me talk for 2.5 hours straight, so you just want 5 minutes? All right. Get up, walk around, shake your arms out or whatever, use the bathroom, drink some water. I'll see you in, we'll say 5 or 6 minutes.
first quiz be on this Wednesday or?
Next Wednesday. We basically haven't done anything yet, so I've thought about being like, all right, we'll have a basically review competing 3 quiz, but yeah. That would probably actually in some ways be the hardest one because you all come in assuming that you know everything that you learned in competing 3, and then you're like, oh, I didn't learn this or forgot this or whatever, and what is this thing? Where the stuff that I assume that you knew in from competing 3 and the stuff that you actually know from competing 3 don't match up. But no, yeah, the first quiz will be next week, Wednesday. Which I believe is in the morning announcements that I know none of you actually read. The morning announcements are actually really, really helpful. Give you a good list of here's all the stuff that you have that's coming up that's due. Alright, that looks like 7 minutes, so let's get going. Hello, welcome back. Alright, so, back half. So, here's the assignments that we have up so far. Normally your programs are going to be due on Monday and Thursday. I figured having something due tonight is probably a little bit short notice. But you probably don't want to just have everything due on Thursday, because then it's like 2 things due Thursday, and I know you'll put them all off until, Thursday, and then not have time to do both of them. So Project 0 is due Wednesday, and then to give you a little bit of time between them, Project 1A will be due on Friday instead of Thursday. And then 1B is due on Monday. There's no quiz this week Wednesday, there will be a quiz next week Wednesday. So on Blackboard we have the new spiffy looking UI that happened, that we got last week. Class recordings will be here. If you click that, you'll get to the spot where you'll be able to see the recording for today after that's done. Notes are here. I have then separate folders for each day. Most of these days are going to have, or in the folders are going to be then notes for that day and also some videos. So the notes are basically the slides that I did in previous semesters before moving into flipped classroom, and then videos are little excerpts for stuff for covering with that topic. You should make sure that you go through the competing 3 review. This is the stuff that I assume that you have learned from previous classes. And sometimes some of the things that I think you should know and the things that you actually know are different. I am just going to assume that you know everything that's in this document. And I'm not going to say, oh, this is going to be a part of your quiz, because I'm going to assume that you just know everything in here. Also, since we're doing flipped classroom-y stuff, you should go make sure that before next time you read the stuff on unit tests and make files and operator overloading, because we're going to do some activities that include these, and I'm going to kind of assume that you know it, and I don't have to go spend the entire time talking about it. Okay. This activities folder, I will post the code that we work on together in class here. I've got sort of a list of here's some of the things that I'm currently planning on doing this semester, and then the activities themselves will appear here after class. And then projects. Your project 0 and project 1A are up. I'll try to get 1B up before Wednesday. And then keep going on from there. Questions, comments, concerns? Alrighty. So, this one's gonna have sort of some talk at you and some we're gonna do some stuff together. So, we're gonna do some big projects in this class. Are you all excited? Very much so? Alright. So much so that you lost your voice, right? Alright, but they're a little bit difficult. There's like, where do I start, right? There's a lot of pieces and it can be overwhelming to try to do everything at once, can't it? You look at something that's sort of a bigger project and you're like, where do I begin, right? If I'm like, alright, so now using all that stuff that you know from committing 3, can you do Evil Hangman? Or is that going to induce panic in you to make you do it? Probably if I said, all right, your project 0 submission is actually, you need to do Evil Hangman by Wednesday. How many of you would actually be able to do that using all of your C++ knowledge? One of you? Okay. So, we're going to do a little bit of thinking here. So there's sort of 2 main ways you can approach a project. Top down, you start at the top, you work down, or you can start bottom up, ground floor work up. So top down, you start with the big picture idea, and you refine it into smaller pieces. Bottom up, you build the small parts, and then you connect them together to make a bigger thing. And you take other small parts and you connect them together to make a bigger thing. And then you take those bigger things and connect them together to make your big project. How do you tackle your projects? Yeah.
It usually depends.
It depends. Yeah, there's some of that. How do you try to go about it?
I mean, I guess you just pick whatever's easier. If it's easier to like look at something at the bigger picture, you go top down.
Mm-hmm. So usually, from what my experience is like, well, I know how to build this little part, right? I know how to build this thing that I think I'm going to need. And I know how to build this thing, and I make them, and then you try to stick them together, and then you get your problems, right? So in my experience, most students try to do some bottom-up solutions, but there's some problems that they run into. There's a bunch of planning that you have to do to figure out what are the parts that I need. And usually the planning this part out is not your strong suit. You don't have the experience for it, right? You're doing this class, you can get the experience that you need to be able to plan out how to do stuff, right? It's a whole catch-22 chicken and egg problem, isn't it? Also, you work on something and then you realize you don't need it, and you wasted effort, right? Or you made some parts and then you try to fit them together and their ends don't match, right? And so then you have to do some more work to get them to actually mesh together, right? And, well, your thing's not really testable until you get to the very end, is it? Is it worked in? Right? Have you ever worked on a project and you made a whole bunch of stuff and you basically didn't know if you were doing anything at all correctly until you got to the very end? And you hit compile and it all blew up in your face? Absolutely has happened.
Don't remember one, but I definitely know it's happened.
You're like probably been there, done that multiple times, right?
Yes.
And by multiple times, some of you are probably like almost every single time. I think I got Hello World to work on the first try, maybe. So top-down design is usually easier. You start with the big picture. You say, here are the main steps I have to do for this project. Boom, we've got a thing that's now in workable order, sort of. You get the very, very basic version of your thing working really quickly. And then you're like, well, this is an approximation. Let's make that part more detailed so it's actually a better representation. Refine it into what does it actually need to do. So this thing is going to be these major steps. And some of those might be temporary solutions, and they need further refinement. But with top-down design, you start with a big, huge, colossal, I have no idea where I'm going problem, right? And you refine it into smaller, easier to think about things, right? So it sort of becomes easier as you go on, right? When you do bottom up, you start with the little tiny things that you know how to deal with, and then you're moving upward to the bigger, more complicated ideas, right? And so in that sense, it becomes harder as time goes on. So we're gonna wanna try to do things in a sort of top-down view, aren't we? Okay, so for that, we're going to work on Evil Hangman now. So as a reminder, because I know lots of you are repressing large portions of Computing 2 from your memory, I know in lab you spent basically the entire semester working on Evil Hangman, sort of. So as a reminder, in the game Hangman, there's two players. One player picks a word, the other player is trying to guess the word. In the video game version of Hangman, the computer is the one who picks the word, and you, the player, trying to guess the word. And so you get to ask a letter. And, the computer will tell you how many letters it has. You guess a letter, and the computer says, yes, it's in the word in these positions, or no, it's not in the word. If you guess wrong so many times, you lose. You get hung, right? If you manage to guess all the letters in the word before you run out of guesses, then you win. In Evil Hangman, the computer cheats. It doesn't actually fix a word till the very end. It's instead able to be like, oh yeah, no, there's no E's here. Nope, no A's either. I swear I picked a word already, and it didn't happen to have either of them. No I's or O's. Okay, I guess there's an U here, right? And then it keeps changing the word every time you guess a letter, so that it's just never that the letter that you picked is not there unless it decides, no, it probably would be more evil to let you have that one. Okay. So I guess let's work on Evil Hangman. So what are the major steps we have to do for Hangman? Yeah,
You probably want to have a structure to hold all the words.
not there yet.
All right.
I know, you're like, all right, so I need this and this and this, right? That's all bottom-up thinking.
Okay.
We need to think top-down. We're going to get to that we need a structure for this and this, but we're not there yet. It's like, we haven't thought at all about how does Hangman work, right? You're jumping straight into the I need to build stuff. And you don't want to start building stuff until you know what you need to build. But we probably do need to set up a structure somehow, right? So we're going to set up a game. But right now, I've just got a placeholder comment for that's the thing we're going to do. I haven't actually made the structure yet, have I? Also, the setting up that structure is only part of setting up the game, right? But I make a game, I set up the game so it's ready to play. Then what happens? Yeah.
Want the AI to be able to choose a word.
That's part of setting up the game, right?
Yeah.
Yeah.
Running the game?
We're running the game. So what happens during the actual running the game part? Yeah.
The user chooses characters.
So the player chooses a letter. Okay. Then we need to check if the letter is in the word. And then we probably need to display the updated game state, right? Arguably, maybe we actually want to do that first here, so that way they get the state before they choose the letter the first time. I could kind of see it going either at the beginning or at the end of this. Check if the game is over. Display results. And that's Hangman, right? So now if I gave you this, could you get Hangman written by Wednesday evening? Maybe? Does this make doing Hangman a lot easier? Yeah? Have we written any code yet? Nope. But we've probably just shaved a couple hours off your doing this project, haven't we? And we did it in like 3 minutes, right? Did we do anything magic here? No. But we've made it a lot easier to reason about this problem, haven't we? Okay. So now maybe we can start with some stuff. So what information do we need to play the game? Yeah.
The number of letters in the word?
All right, so we need to know the word size, and we also need to know
The number of guesses?
number of guesses. Okay, and yeah,
How many trials do you have?
that's the number of guesses, right?
Oh, yeah.
We also need the list of words, right? Or the dictionary. Oh, I need to copy my dictionary over from previous semesters. Let's go get that. Dictionary, copy. All right, have a dictionary. Okay, so we need to read the dictionary, and unfortunately we don't really have an easy way to skip that. So how do we want to store the dictionary? Yeah, somebody.
Set.
And a set?
Yeah, when you went in order set, so that it's in get the wording so they can work.
Do I care if they're actually ordered? But also my dictionary is in fact already ordered. Yeah,
Yeah, vector, I guess.
probably a vector, yeah. So we'll include vector Alright, so we need to get a list of words. So that's probably a vector of strings, right?
Too many chevrons.
What?
Too many closing chevrons.
Oh, too many, yeah. I'm like, in C++11 they let you put chevrons next to each other, but it's like, oh wait, I only need one set, not two. Alright, and I guess we'll need to open a file, right? So, alright, so standard input file stream file, we're gonna read the dictionary.txt file, right? Okay. So while we're not end of file, right? So while there are words, then we get a word and we'll push it into our dictionary, right? That itself took you like a week in computing 2, right? You spent several weeks building up your string, you got the vector directly from Dr. Adams, and then you spent a week just reading the dictionary from a file, right? Wow, we have nice tools now, don't we? All right, word size, we're just gonna hard code that for now. And number of guesses, we'll hard code that for now too. Those numbers look fine, or do you want different numbers? Look good. Okay, in computing 2, you had to actually ask the player, right? But we'll leave that as an exercise to the reader. You guys know how to do that, right? So here, we're not going to worry about the details. The how do I get the number, or the word size and the number of guesses, that's somebody else's problem, right? That's future us's problem. Before the end, we'd want to replace this with a call to something to ask the player, but for now, we don't really care, do we? Okay, so I guess now we probably should make some sort of game structure, right? So, class hangman. Okay. So we probably, I guess, need a... So we're going to take a const standard vector of string reference dictionary, and then the word length and the number of guesses, right? I guess we need to include string also. Okay. What information do we actually need to store? Yeah.
The chosen string.
Hmm?
The chosen string.
Chosen string. Not yet. So we're taking as parameters the dictionary, the word length, and the number of guesses. Which of these do we actually need to keep? So one thing to remember is that we're not choosing a word, right? We're being evil. So we're gonna have a bunch of words that we can choose from at any point in time, right? So we need to keep track of what words do we have to choose from, right? If we just pick one word, we're stuck with a word, right? So we're gonna have a vector of strings of the words that are left, right? And how many guesses do we have left? I don't need to keep track of word length beyond the constructor, because I'm just going to filter the list to keep only the words of the right length. So guesses left, I'm going to initialize to number of guesses. And now is going to come the fun part. Include algorithm, include functional, copy if. I think I also need iterator. So copy if. Any of you used this function before? Cool, new thing already, right? So copy if is a function that copies from one structure to another if they meet some condition. So we're going to copy words from our dictionary. Let's dict.begin. So it takes the begin and end iterators from the list that you want to copy from. So we're going to copy everything from the dictionary into, so then it takes an iterator that will copy into. And so we're going to use a special back inserter. So back inserter is a special iterator that when we assign to it will append to our vector. And then comes the fun part. The last thing that it takes is a function that that returns true or false. It's going to pass into the function one of our words, and if that function returns true, it will copy it into our words. If it's false, it's going to skip it. Well, we don't have a function, so we're going to give it one, or we're going to make one. And this is going to be a lambda expression. So our lambda is going to take a string and we're going to say, well, we'll take it if W's size is num guesses.
Shouldn't it be word length?
Or sorry, is word length. Yes. Thank you. And we're going to have to then capture word length. Okay. This is a lambda expression. C++ has the worst syntax for lambda expressions in any language I've seen that has lambda expressions. By far. So, this is going to copy from dictionary into words all cases where the word size is equal to word length. We'll talk more about making lambdas later in the semester. Right now, I am showing you a couple. Questions? This probably would have taken you an hour in computing 2, wouldn't it? We're so much stronger already, aren't we? Nowadays, you probably would have been like, all right, for loop, go through, and then call push back, right? Not too bad. But it's good to see the lambda expressions, isn't it? Okay. So then we're going to make a hangman game. We need to include hangman. And it needs to take in our dictionary, the word length, and the number of guesses. All right, we good? Yeah.
Quick thing. When I declared the fin or for the dictionary of text reading, it's giving me error for some reason.
Did you make sure that you included upstream?
Oh, I think I put iStream by accident, that's why.
You need a file stream.
Ow.
We've got IO stream and fstream.
Okay.
All right. So, okay. This part here is a big loop, right? So while not game dot is over, all right, so I guess we're gonna need to add a bool is over function. Hangman is over is a bool function. It's const, and we're just gonna return false for now. The game is never over. Placeholder, right? That figuring out if the game is over is somebody else's problem, or is future us problem, right? I can make the stuff inside the loop work without having figured out exactly the details of the loop condition. Right? Okay. Display game state, choose a letter, check if the letter is in the word, check if the game is over. All right, we did the check if the game is over part, right? Okay, what part do you want to tackle next? Somebody make an opinion.
Display game state.
Display the game state. All right, what do we need to do for the display state? We need to display the current pattern that's been picked, right? Okay, and also the letters that have been guessed, right? So, oh, and the number of guesses left. So display pattern display letters left and then display guesses, or guesses. Not letters left, letters chosen and guesses left. Right? Okay. The last one sounds easiest, doesn't it? We'll see out game dots guesses, which means we'll add a helper function here. Okay. All right, that part was easy, right? Okay. Letters chosen sounds like the next easiest thing, right? All right. There was a structure someone talked about earlier that I think might be useful here. What was it?
Maybe sets.
Sets, yes. What kind of set do we want? Character. All right, so we'll have a function that returns a set of the characters we've chosen, which means that we probably need to have a set of the characters chosen, right? All right, so standard coutts are, so for each character C in game dots, letters chosen, standard coutts, that letter and a space. Okay. Then what? Now we need to display the pattern. You want to come back to that in a little bit? Let's get it so that it's interactable so we can see stuff happening. So player chooses a letter. How do we do that? Yeah. Prompt them to enter a letter. Guess a letter. Okay, then what? Create a character variable and ask for input. Cin into character. Okay, that part was easy. And then we check if the letter is in the word. All right, so some sort of if game.guess character. Cout character is in the word and otherwise hit that twice. Otherwise, standard cout character is not in the word. All right, so I guess we need a guess function. Okay, and so what happens when we guess? Yeah.
If you guess wrong, number of guesses go up.
So the number of guesses goes down
Down.
because we lose guesses every time we guess. We need to add to list of guessed letters, and we need to check if in Word. Right? Well, the add to the list of guessed letters is easy, right? So we have the letters chosen dot insert. So insert. No, it's guessed letters. Guessed letters insert character. Check if it's in the word, we'll deal with that later, and number of guesses goes down. For now, we'll just say they guessed wrong. So, guesses left goes down. Return false. So right now, we're just gonna be like, it's not in there, right? And so now we can go back to our is over and say, we'll say it's over when guesses left is 0. And now we can check if the game is over. Or so now we've done all of that. Display the results. So if I guess game dot is 1. Standard cout, congratulations. Else, did it again. Standard cout, sorry. Later we'll probably want to display what the actual word is, right? All right, so we need also a bool is 1. So bool hangman is 1. Const. So if they run out of guesses or the game is 1, then it's over. Okay. So, make, what did we mess up? Function main, undefined reference to hangman constructor. Oh, because I've got a make file that needs some fixing. So, our dependencies, we require the hangman.hpp file. We're going to need the hangman.cpp or .o and main.o, and we're going to call our program hangman. All right, there we go. Oh, and then it doesn't like the fact that we're comparing different signed things. because word length is an int and it probably should be a size 2. Which we'll also need to change here. And up here. And line 14 value computed is not used. Oh. In every other language with lambdas, you don't put a return in your lambda. Undefined reference to letters chosen. All right. Guess the letter. A, E, I, O, U, S, T. Our game's sort of playable now, isn't it? Is it done? No. But it's now in a state where we can actually test stuff out, right? We could have gotten into the state a little bit faster if we really wanted to, but it sort of works, right? How many of you, this is currently better than what you actually submitted for Evil Hangman Competing 2? Couple of you. Okay. So I guess we have a few things that we need to fill out, don't we? We still need to display the pattern here, right? We'll need to pick the word at the very end. And we need to check if the game is won and if the thing's actually in the word. Which do we want to do first? Yeah.
Just check if the word, if it's in the word.
Check if it's in the word. Okay. That's probably the hardest of the things to do. Okay. Check if it's in the word. So I think in order to do this, we're actually going to want to do this first. Display the pattern. Because to be able to decide which words we're going to keep, we have to know the pattern, right? So we need to, let's figure out how to get that pattern first, right? Okay, so for each word, we're going to have to convert it into a pattern, right? So we're going to make a function that is going to convert a word into a pattern. Okay? Copy and paste. So, how are we going to convert our word into a pattern? So we're going to have to, oh, yep.
I don't need to put name in before mask.
Oh, yes, thank you. Okay. So, how are we going to convert the word into a mask? Did I do transform or did I just do a forge? I did a transform. All right, let's do that. I like transform. So we're going to teach you another. We're going to do another lambda. So we saw copy if earlier. So copy if copies a thing if it meets some criteria. So we're going to do a similar thing using a function called transform. So we're going to iterate over the word. We're going to use, again, a back inserter into our pattern. And then we're going to write a transformation function. So, what are we going to check? So we're going through, we look at a particular letter in the word. What are we going to look for? Or what are we going to do with this letter? So I have the word pizza, right? And I look at the P. What am I going to do with the P? I have to make a decision, right? I guess first is, the question is, am I going to do what with it if it's yes, or what with it if it's no? What are my options? Do we need to play a game of Hangman so you figure out what it is that we're trying to do here? So when you do, yeah.
If the letter they guess is correct, or if the first letter in the word is correct and they guess the right one, then you
So-
can keep that word.
We've already made guesses, right? So we have this set of the guessed letters, right? So now we're looking at a word and we're wanting to compare it to those guessed letters, right? So we're going to take a word and we're going to convert it into a mask. So the letters that they've guessed, we're going to show. And the letters that they haven't guessed yet, we're going to hide, right? So, if guessed letters, what was it? Is it letters guessed? Guessed letters. Dot count C. The count is sort of the standard way of checking, is it in there? If it's in there, it's going to be 1, which is true. And if it's not in there, it'll be 0, which is false. So if it does contain this letter, what do we return?
C.
The letter. And if it's not in there, what do we return?
Underscore.
Underscore? You want underscores? I don't really care whether you want underscores or dashes. Okay. So now we have a way to convert a word into a pattern. So this transform function will go through every letter in Word and insert it into pattern. But if the letter is guessed, we return the letter, and if it's not guessed, we replace it with an underscore. Yeah,
Semicolon at the end of the planned expression.
thank you. I'd so much rather be working in Python or Scala and not have to worry about semicolons.
What about Kotlin?
Add. I did a Kotlin tutorial once. It hasn't really stuck with me because I haven't had a chance to keep using Kotlin. Okay. But all three, the lambdas for all those languages are much better than C++. Of those three, Python has the worst of the lambdas, which are okay. Okay. So we have our mask function that can mask a word now. Okay. So we probably want, or so we want to be able to display the guessed pattern, or sorry, the current pattern, right? I think this is a thing where we're going to want to have a string field. And we're going to need to initialize that. So current pattern is going to be a string of going through all the alternate constructors. Where's the one we want? All right, size first. So that's going to be word length, and it's going to be filled with underscores. Oops, we need to also print that, don't we? So standard cout game dot get pattern. So we have 5 underscores. We've chosen no letters. We have 7 guesses left. A, E, I, O, U, Y, S. All right. Game's starting to come along, right? All right, so now we have to check if it's in the word. This is where we have to start, and we're going to then have to reduce the words to only the one that matches the pattern, right? So trim words that don't match pattern. Okay. Well. So for each const auto reference word in words, let's do a standard map of string to vectors of strings. So, how many of you have used map before? How many of you have used map? No? That was something that probably took you a couple weeks to make in computing 2, wasn't it? The associative structure that says, well, here's our patterns, here's the list of words that have that pattern, right? So string P equals mask W. So we mask the word, get the pattern for it. And patterns for that P dot pushback W. So after this loop, I now have a dictionary, or I have a map. The keys are all of my patterns. The values are the list of words that matches that pattern. So we need to pick a pattern. I'm going to pick one of them arbitrarily. Begin first. All right, we're picking one of them arbitrarily for now. That's going to be a to-do. We'll pick a different one to be evil. I'm going to pick whichever one happens to be first in my map. All right, so at this point, we've picked a pattern. So words equals patterns sub new pattern. We're going to replace the list of words with the list of words that match this particular pattern. All right. Or actually, better thing to do probably might be to say string old pattern equals new pattern. And then we'll just make pattern be the one chosen arbitrarily. This equals pattern. We'll pick pattern arbitrarily. Is it chosen pattern? What do we call it? Current pattern, blah. So many different ways to name things, right? All right, so number of guesses goes down if we get it wrong, right? So guesses left minus equals old pattern is not the current pattern, right? Or sorry, is equal to the current pattern. If they're the same, the guesses goes down. If they're different, then we guessed wrong. Or sorry, if they're the same, we guessed wrong. So we want them to be different to succeed. Woo! Make. So, guess a letter. A. Next.
C.
C.
S.
S. E is pretty common. O. I. T. All right, let's go give ourselves some more guesses. A, B, C, D, E, F, G, H, I, J, K, L, M, N. All right. actually include unordered map and switch to that, because since that, so the issue that we're having is since the empty string is always the first thing, that's what we're picking. Although I would think that by, you know, half the alphabets, we should end up with something. Hey. You think geese?
Yay. But it didn't end.
We need to finish up the, alright, so we need to fix the is one now. So it is one if current pattern dot count, we have standard count current pattern dot begin, current pattern dot end, instances of, we said underscore, is 0. So ESG. All right, congratulations. All right. All right, and then we want to be evil, right? Yeah, a question?
Didn't we want to display the word too?
Do we want to display the word at the end? Yeah. The word was game.word. Do you want to pick one randomly, or do we want to just get the first word? Let's just get the first return words sub 0. Yep. All right. All right, so we just need to be evil now, right? So, all right, let's do standard max. And so there's a version that's going to take our iterator and a function that we're going to use for comparison. So patterns begin, patterns end, and our comparison function. We have two vectors, right? Or, sorry, we have two pairs, P1 and P2. And so we're going to want to max by the number of words in the vector, right? Patterns begin, iterator of pairs? I thought it was a pair. Okay, it's an iterator of pairs. So current pattern is going to become that. So, this whole thing here, we have that dictionary now where we say, here are all of our patterns, here's the vector of words that go with that pattern, right? We're going to go through, we're going to figure out which one of them has the most has the most words in its vector. We find the max, we're going to take the pattern that goes with that one. We're going to use that, that's going to give us then the most opportunities to be evil. So that's always fun to see, right? Oh. C++, I'll go to the library. Make sure I got everything right in there. Non-modifying, count range, mismatch, ranges, find, end, adjacent, search. Starts with, ends with. Those are the modifying ones, partitioning, sorting, binary search, heap operations, min-max. So we want, oh, actually, I think we want max element. Which now then this is a dot here and here. Oop. But then that returns a pointer. Okay. Shoot. E. There we go, that's better. All right, sorry, I wanted max element that returns the pair, and then we're going to get, or it returns a pointer to the pair, and we get the first thing out of that. Yeah, otherwise the description I just gave is correct. Okay. Questions on what we did here? Our game is now evil, isn't it? Is E-A-S-I... What more do we want to guess?
P.
P?
T.
T?
B.
B?
O.
Hmm?
O.
O?
U.
U? Hey, we got a U.
C.
C?
T. Oh, T's
We
are
got T
in.
already.
H.
H?
R.
R?
D.
D?
V.
V?
V.
N.
N?
F.
F?
G.
G?
X.
X? The word was mummy. All right, were we evil? Extraordinarily, right? So we got a complete Evil Hangman game in about an hour, right? I guess a little under 50 minutes. Or about 50 minutes. There's, you know, for your actual one for competing 2, you had to add the ask them if they want to play again, and to ask them how many letters and guesses they want, right? But that's all easy stuff you could do really easy, right? So basically we just did Evil Hangman in an hour. And we saw a few new things. We saw lambda expressions. We saw the copy if function. We saw the max element function. We saw the transform function. We'll talk about these functions and lambda expressions more later in the semester. But I wanted to start getting you a chance to see them early. Questions? Do you feel a lot stronger than you were last semester now already? Maybe a little bit? We'll ask at the end of the semester if you feel more powerful than you did at the beginning of the semester. Hopefully the answer will be yes. All right, questions, comments, concerns about anything? Yeah,
Are you gonna upload this?
I will upload the code this afternoon. Any other questions, comments, concerns? All right, have a good day, everybody. I will see you on Wednesday. Make sure you go look over the note stuff before then, and we'll end up talking about operators, unit testing, and makefiles.